And the numbers that we have in number 41 are 66 and 90. And our guess was that the GCF was 3. That's the only thing anybody told me. Okay, so you might have a different guess, but you didn't share it. All right, so here we go. How do we know for sure that it is 3 and it's not something bigger? You could go out to the side and use a factor tree to see if you could figure something out, but here's what textbooks tell you to do. Go ahead and prime factor 66. So actually, I am going to make a factor tree. We know what goes into 66. 6 times 11. 11's prime is 6 prime? No, it is 2 times 3. So I'm going to write down the factors in the order, smallest to biggest. And I'm not going to use exponents here because I want to make sure that I'm, that's not going to be helpful, in other words. Now 90, if I go do a little factor tree for it is, what do you think about 90? Yeah, 10 times 9 is usually what everybody remembers. 10 breaks down into 2 and 5. Those are prime. 9 would be 3 and 3. So if I write them in order, I'll have a 2, and I'll have 2 3s, and I'll have a 5. Now what we do, if you look, what we've done is we've prime factored, right? And then what do we do next? We look for what all is in common. Remember this now? It's just you didn't have numbers that were this big before. You got a 2 in both of them, okay? So my GCF's going to have a 2 in it. Is there anything else in common? The 3. Okay, so there's 1 3 in common. My GCF will have a 3 in common. Anything else in common between the two? No, so my GCF is 6. So it's easy sometimes not to, just because we maybe have numbers that we're not that familiar with, just not to know what all the biggest factors are. So this is the process you do in that case, and that's what we're going to do with 43. 43. Okay, so 43, the numbers are 182 and 196, and I'll be honest with you, the only thing I could even guess at here might be 2 or maybe 4. I'd have to divide them out to see if 4 would go in there, because I don't know. So we want our GCF. So remember, our steps that we're going to do here is we're going to prime factor each, and then we're going to see what they have in common. What they have in common, the factors they have in common, or it's the GCF, greatest common factor, right? GCF, greatest common factor. What factors are in common? Okay, so I'm going to go make a factor tree because I have no clue. I know 2 goes in there, so that's good. I can break that down really quick into 91. Does anything go into 91? Do you think anything that goes into 91? 7? Let's try it. This is kind of harder than you might think. 7 goes in there one time. 13. Okay, so isn't it kind of hard to know when you got it all the way down? Because if you don't know what 91 is, it gets difficult. So until you know for sure that a number's prime, try like 3, 7. 11's pretty obvious usually, right? But 13, maybe 17's another prime number. So maybe try some of those numbers just to check it out and make sure that they actually don't go into it. Okay, so we got 182. Let's write them in order. It's 2 times 7 times 13. And even I had trouble thinking about 91. I would have had to sit and play with it. That's why you got a calculator. That's what a calculator would be good for, right? You could quickly just divide out some of those prime numbers into it. All right, 196. Yay, another even number, right? So we know 2 goes into it. I think that's, 98?
98 and then 4 times 49.
Okay. Now, how did you know? Did you know?
I just kept going.
Okay. So, yeah, 2 goes into 9. If you keep going, like even with just the even thing, 2 goes into 98 49 times, and 49 is 7 times 7. So as long as it's even, you can do this, at least do this. If it's even, keep dividing by 2. You might even try 4 or a bigger multiple of 2, just to make it go faster. So this would be what, 2 times 2 times 7 times 7? What do they have in common? Yeah, there's a 2 here, so I'll write it. I'll use different colors for each thing I circle. There's a 2 in common, and each of them has a 7, and then that's it, right? So my GCF is 14. And again, this is going to matter to us in a section or two, probably even next section, because they could have given us a problem like 182x squared minus 196, and we're going to have to factor it. So we would say the biggest thing I can pull out of there is a 14. The good thing about prime factoring it, if you know that you're pulling a 14 out of 182, doesn't that mean that the only thing that's going to be left is a 13 since you've prime factored it? You can actually look. You see up here, the only one I didn't circle on 182 was this 13 right here, right? Isn't that the only thing left that wasn't in the GCF? So you know it's the leftover, okay? And then 196, when I took 14 out of it, there was still a 2 and a 7, right? So it would be a 14. Ignore that. That's just what happens when you use your phone as a bell. So you get everything that comes across the phone. So we're going to do something with it, which is the reason we're practicing this now, okay? It's not just oh, that word boring stuff again. I'm going to have to do it again, and I'll learn some real math. We're actually going to use this for our real math that we're getting into. Go away already, okay?